Lesson 5.3 is on basic loans using compound interest. So just to review, an annuity, so we define annuity, is a series of equal payments made at regular time intervals. So equal payments made at a regular time intervals. There are different forms of such as the one shown below. It could be a regular savings, it could be paying off a loan or a mortgage or a retirement income. Okay, so using a TVM, so in lesson 2 we use a TVM calculator to solve non-annual compound interest problems. So again, the interest is given or compounded. It's either semi-annually, quarterly, or it could be monthly, and actually it could also be in terms of weekly. So PY represents, so in the particular case, PY represents the number of payments so PY represents the number of payments PMT made to the investment or loan. For questions with no payment, you need to make PY the same as CY value. Okay. For a question with payments, the PY value is equal to the number of payments made in 1 year. So therefore, for example, if you're paying quarterly, so quarterly in a year, you are making 4 payments in 1 year. So using TVM to solve annuity problems, an annuity involves making equal periodic payments. Note the following points when solving annuity problems with TVM. The PY value, so the PY value is equal, that is equal to the number of payments, again, payments made in 1 year. So made in 1 year. Unlike questions with no periodic payments, the PV, or the present value or the initial amount, may be 0 or not. If PV is 0, it indicates there is no initial amount. So again, if you have a PV that is 0, it indicates that no initial amount. But there are regular periodic payments. If PV is a number other than 0, so if PV is a number other than 0, then the initial sum of money was invested or borrowed together with the regular periodic payments. So let us consider this particular example. So consider the following loan problem. So Thomas Cruiser borrows 7,500 from a bank to buy a used car. The bank issuing him the loan charges 8.25 interest per year compounded monthly. Okay, so if Thomas makes 175 monthly payments at the end of each month for 4 years, how much, so the question is, how much of the loan does he have left to repay? So again, the interest rate is 8.25%, but it's compounded monthly. So compounded monthly here. And the regular payment monthly is 175, and it is made at the end of each month. How much of the loan does he left to pay? So question A, why would this type of loan be considered an annuity? Well, it's an annuity because equal payments of $175 are being made. So are being made each month. Okay. So we need to complete the following to answer the question in the scenario using the TVM solver. Again, we're using the TI-84. So if you have the TI-84 with you, the software that I gave you, you can use that one. So the interface of such calculator is shown here. So this would be the one that you will be seeing. So for the question, what is the PMT value and why is it negative? So PMT is the payment. PMT again is the payment made each month. So PMT should be 175. So PMT is equal to negative 175. So I'm gonna place here negative 175. It's not negative because it's so again by default this calculator uses the convention of negative if it's coming out from your own pocket. Negative since it is out of pocket. Okay, it's an expense, that's why it's a negative. And explain why the entry is n for n is 4 times 12, which gives you 48. Well, that is coming from the statement of each month, the payment is made each month for 4 years. So this is 4 years. And there are 12 months in a year. 12 months in a year. So the total number of payments would be 48. So again, this would be 12 payments per year. 12 payments per year. So what is the present value? So what is the present value? So the present value here would be, well, if you can see, you borrow 7,500. So the present value of your loan is 7,500. So I'm gonna place 7,500 here. And why do you think it's positive? Well, positive because money, so money is received. So into pocket, into your own pocket at the start of the loan. At the start of loan. So it's just a matter of convention. You use a positive value if it's being received or an additional amount. In your case, you have an additional money that was in this case, well, a loan is something that is given to you, but of course you need to pay that one. Okay, so if you're gonna pay for your loan, it's something that's taken from your own pocket. That's why it's negative. And why does PY and CW 12? Well, PY stands for payments per year. Well, you paid monthly, so in a year you have 12 payments, as well as Y, it's compounded monthly, so therefore you have all in all the interest is compounded 12 times in a year. Okay, so I would say that monthly payments, so you're doing monthly payments, monthly payments are made, and interest is compounded monthly. Okay, so it doesn't necessarily have to that your PY, again, PY stands for payment per year, the number of payments in a year, and CY is the compounded, how much the interest is being compounded in a year. So doesn't necessarily mean that this should be equal in all of the cases. It can be different. Okay, so how much does Thomas still owe the bank at the end of 4 years? Okay, so at the end of 4 years, remember that you're paying each month, and then for 4 years, that's why the number of payment is 48. In total, you're paying your bank 175 each month. So at the end of 4 years, if you can see the future value in 4 years, that would be, so if you can see here, so the future value after 4 years is 508. Okay, so that means that you still have to pay that particular amount. So 508.52 are rounded off to the nearest cent. That would be $508.53. So I just disregard the negative sign there, because I know it's something that you need to pay still the bank. Okay, so for letter D, adjust the TVM solver so that Thomas pays off the loan. How many months does it take for Thomas to pay off the entire loan with the same monthly payments? Round up to the nearest month. So for letter D, what you need to do is you set your future value to 0, because it must be solved, and I mean, you need to pay off everything, right? So future value means that if you're gonna pay it off, well, the value is already 0, and solve for n. So this time for letter D, you're solving for n, and if you're gonna do that, you'll get around 50.94. So that would be rounded off to the nearest month. That would be 51 months. So it would take 51 months for him to pay off his loan. So for letter E, how much did the car really cost Thomas? So for this particular question, remember that he borrowed 7,500 to buy a car. However, since or because of the interest of 8.25 interest, you're gonna expect that the one that he paid to the bank to buy that particular car is no longer 7,500. So it should be more than that. So what we can do is, assuming he paid 175 up to the last month. So the total payments would be equal to, so again, it would take him 51 months. So that's from the previous question, 51 months. So 51 times $175. So that's around 8,925. So that means the cost of the car is really 8,925 because that's the total amount that he paid for that particular car. So again, you can expect that it should be more than 7,500. So there's a total interest of around 1,425. Okay. Again, well, the bank usually, that's how banks get their profit, mostly from debt or from loans of individuals, or could be to companies. So let's take number 2. Dharma Asphalt applied for a loan to have her basement developed. The contractor she hired estimated that it would cost her approximately $13,700 to develop the basement. Dharma had already saved $7,000 towards home improvement. So she received a loan for the remaining amount and paid it off in 4 years, with payments of $175 made at each end of the month. What was the annual interest rate to the nearest 0.1% if the interest was compounded quarterly? So quarterly means 4 times in a year. Okay. So what you can do is, again, we use a TVM calculator, and you have this particular window that you can see in that calculator. So the key here is actually just knowing where to plug in the values that you need to input in your calculator. So let's say for n, well, so in 4 years, and he paid monthly. Okay, paid monthly in a year. So that means in 4 years. So that would be, so the loan, 1 in 4 years at each month. So every month. So that means that the payments it's made every month in 4 years. So that would be 4 times 12 here. So that would be, well, actually in your calculator you can just place 4 times 12, or you can just place that's 48. Interest, well, that's the question. And then the payment is 175. But again, the payment is something that is taken off from your own pocket. So we use the negative sign for that. And then we want to pay it off. Okay. So he wants to pay it off in that particular span of time. So that means that the future value is 0. Okay. Now, PY is again the number of payments in a year. So is it not that he's paying each month, end of each month. And then that's monthly, so there are 12 months in a year, so that's 12. But the interest is compounded quarterly. CY stands for that. So therefore, CY is equal to 4. And again, it's paid at the end. So end is, so I gonna choose the end as the option there. But how about the present value? Well, the present value is the one that you loan from the bank. But remember, you already have the amount of 7,000. So the loan amount, therefore, the one that, or the amount that she loaned is just the difference of 13,700 and the amount that she saved. So the difference between the two should be the cost of that loan. So if you're gonna take that one, that's $6,700. So that means that the present value, or this is the loan amount, that would be 6,700. Again, this is the loan amount. Again, it's positive because it's something that, well, it's added in your own pocket. Now with this one, we can solve for the interest. Okay, so the interest, if you're gonna solve for the interest, that would be 11.6739. However, you need to round it off to the nearest tenth of a percent. So tenth of a percent. So that means that you're gonna round it off up to here. So that means that that would be 11.7%. So therefore, you would say annual interest rate is equal to 11.7%. Remember that the percentage here, I% pertains to the annual interest rate, or the interest in 1 year. Okay, so just be careful with that. Again, that would be your I. So this would be your I, 11.7%. So at this time, before proceeding to the next section, for today, you need to complete questions 1 to 7. And again, before the end of the session, you need to submit your work. Again, just answer as many as you can. So if you're using a different TVM calculator, it is to be expected that somehow there is a difference in value, but the difference should be would be very small. Okay, because even if you use a formula for this one, you'll get a different answer somehow with the TVM calculator that you will be using. So the answers in the book, if you're gonna check that on that, if you're gonna compare it, the answers in the book are based on the TI-84 TVM calculator. So if you're using the TVM calculator, whatever you will get, that's also the answer, should be the answer in the end of this particular assignment.